All right, so we have these what are called identities to help us simplify complex trig expressions down to more simplified versions. Anytime you see x, that's the same thing as us talking about the angle theta. Okay, so I just replaced theta with the variable x, but you could use any symbol. All right, so you can see it with a or u or whatever, or theta, but it all means the same thing. So these identities, we have 6 reciprocal identities and 2 quotient identities. The reciprocal identities, again, you just have sine is the same as the reciprocal, which is 1 over cosecant. Okay, remember, sine and cosecant go together. That means that cosecant is 1 over sine. Cosine is 1 over secant, so secant is 1 over cosine. Tangent is 1 over cotangent, so cotangent is 1 over tangent. So you want to memorize all 6 of these identities. So it's really easy. All you have to do is write sine x, cosine x, tangent x. Then write their reciprocals. Cosecant, secant, cotangent, just like we did in Unit 9. Then write their reciprocals. Okay? You can see 1 is in the numerator on every single one. Right? And then just put the denominator. All right, then we have 2 quotient identities. Okay, so tangent from the reciprocals is 1 over cotangent, and cotangent is 1 over tangent, but tangent and cotangent can also be written in a different way. So tangent is also sine divided by cosine. So this comes from the unit circle. If you remember, the tangent is the y-coordinate divided by the x-coordinate. And the y-coordinate was the sine, and the x-coordinate was the cosine. And so if you do y over x, that's the same thing as saying sine over cosine. Cotangent, from the unit circle, that was the x-coordinate divided by the y-coordinate, x over y. So then x is the same as cosine, and sine is the same as y, so it's the same cosine for cotangent. All right? So anytime we see cosine over sine, we can replace it with cotangent. Anytime we see sine over cosine, we can replace it with tangent. Anytime we see any of these fractions, we can change it to one of these reciprocal functions. All right, and so that's what we're doing as far as simplifying trig expressions. We're trying to change it from something complex into something more simplified. All right, now these are all different strategies that we can use to simplify. This main one, number 1, changing things to sines and cosines is going to help a lot because then we can use PEMDAS, order of operations, we can cross cancel, we can add or subtract fractions. So all things that we can do with algebra problems, we can do with trig problems also. We can factor, we can distribute, all that stuff. We can combine like terms, we can square root, we can square when we're solving problems. So let's go ahead and practice simplifying these 3 real quick. All right, so again, one of the main strategies is to change things to sines and cosines, so things start to cancel out. All right, so on number 1, we have cosine x times tangent x. So I can change tangent x to something else. I can change it to sine x over cosine x. All right, now I can replace or just change cosine x. I can write it as a fraction by putting it over 1. And because I'm multiplying fractions, I can cross cancel. And so if I multiply what's left, it's sine x over 1 or just sine x. Right, so that simplifies down to just sine x. Remember, when they cancel out, it's not going to 0, it's going to 1. So when you're cross canceling, these are just going to 1. Okay. All right, number 2, secant x times cotangent x. So again, we're using our reciprocal. The reciprocal identities are going to come into play a lot. So secant x is the same as 1 over cosine. Cotangent is cosine over sine. Again, I'm multiplying, so I can cross cancel these. And so I have 1 over sine x left over. And then I can change that to cosecant x. All right, number 3, cosine x divided by cosine squared x. All right, so this, in simplifying, works the same as in algebra if you had something like x over x squared. Because the bases are the same, we could subtract exponents. All right, so if we were simplifying x over x squared, this would just simplify down to 1 over x. So I can do the same thing on trig expressions if they're the same. So cosine x divided by cosine squared x, I can cancel this cosine x out with one of these cosine squared x. And so remember, there's a 1 left on top on this. It's 1 over cosine x. And then this will simplify to secant x. All right. So if we look at our unit circle, radius is 1. And we drop down a vertical line, the x-axis, we create a right triangle. So this is the x length, this is the y length, this is the ordered pair x comma y on our unit circle. Well, we can use the Pythagorean theorem, a squared plus b squared equals c squared, to come up with an equation. So if this is x, then this is y, and this we know is 1, then x squared plus y squared equals 1 squared, or just x squared plus y squared equals 1. So this is just using the Pythagorean theorem, a squared plus b squared equals c squared. Right, to get this. Now, if we take this Pythagorean theorem and we replace x with its trig equivalent cosine x, and we replace y with its equivalent sine, okay, then we get what's called the Pythagorean identity. All right, so we're just using the Pythagorean theorem. So we're replacing x with cosine theta, we're replacing y with sine theta, and so we get cosine theta squared plus sine squared, sine theta squared equals 1. Then what we can do is eliminate the parentheses, all right, and just bring the square in on the trig expression. So we want to write it as cosine squared theta plus sine squared theta equals 1. We don't want to put the square on the theta, or on the angle. Okay, bring it inside, in between. Because these mean two different things. All right, so cosine squared plus sine squared equals 1, or we could flip this around using the commutative property, sine squared plus cosine squared equals 1, same thing. So what this means is anytime we see a cosine squared plus sine squared in the problem, we could just cross it all out and put 1 there instead, because that's what it's equal to. All right, now if I take the Pythagorean identity, cosine squared plus sine squared equals 1, or sine squared plus cosine squared equals 1, all right, I can create 2 additional identities from this one right here. So I wrote it twice just so you can see how I manipulate it to get 2 more identities. So what I'm going to do is take the sine squared plus cosine squared equals 1, and I'm going to divide every single term by sine squared. Then I can use my reciprocal identities and quotient identities to simplify it even further. Right, so I'm just going to divide everything by the same thing, which I'm just going to use sine squared to do this. Now I'm just going to simplify each fraction. So sine squared divided by sine squared is 1, plus, now cosine squared over sine squared, that's using the quotient identity, cosine over sine, which is cotangent. So cosine squared over sine squared is cotangent squared. Equals. Now 1 over sine squared, I can use the reciprocal identity. 1 over sine is cosecant, so 1 over sine squared is cosecant squared. So this gives me another Pythagorean identity to use. All right, then I can take the exact same main Pythagorean identity. This is the main one always. And then I can divide everything by cosine squared and do the same thing. All right, so simplifying each fraction, sine squared over cosine squared, according to the quotient identity, will be tangent squared. Plus cosine squared over cosine squared is 1, equals 1 over cosine squared, according to the reciprocal identity, is secant squared. So this gives me another one. All right, so I have all three of them listed here. Okay, so these are the three main Pythagorean identities. Now, with each of these three, I can create two more. Okay, so if I take this main one, sine squared plus cosine squared equals 1, I can subtract something over to the other side, and I create another Pythagorean identity. So, for example, I could take this and subtract cosine squared over. Okay, and if I do that, then I get sine squared by itself, which will equal 1 minus cosine squared. Well, I could take this same one and get cosine squared by itself by subtracting sine squared over to the other side. All right, so I'm going to get cosine squared by itself. So I'll subtract sine squared over. So then that means from this one, I created two other ones. Okay. Now I can do the exact same thing for these two by just subtracting something over. Right, so go ahead and try to create the other four. So 2 for each one. So you're just subtracting something over. All right, so here's the there's 9 versions of the Pythagorean identity. 3, 3, All right, so make sure you have all those written like that. And then we're going to use them. All right, so go ahead and turn it over. So we're going to do these out of order. We'll do the easier ones first and then more complex ones. All right, so let's start with number 5. 5's pretty easy. Tangent x times cosine x times sine x. So again, one strategy that you can use to simplify is change everything to sines and cosines, because you might be able to cancel something out. Right. So tangent x, I can change to sine x over cosine x. And then everything else is already in sines and cosines. I'm not going to change those. I can write each one as a fraction by putting it over 1. Now, because of multiplication of fractions, I can cross cancel. Right, so I can cancel the cosine x's out. And then multiplying what's left, sine x times sine x is sine squared x over 1, or just sine squared x. Remember when you have a square like sine squared x, don't put the square on the x. Okay, put it in between. All right, let's go down and do number 7. 7's pretty easy. 1 minus cosine squared x over sine squared x. So anytime you see a trig expression that's squared and there's a 1 involved, like a +1 or a -1, look for a Pythagorean identity. Okay, go to your 9 Pythagorean identities because you should be able to simplify something. So if we go back to our identities, we're looking for something that has 1 minus cosine squared in it. All right. And so we can see it's right here. 1 minus cosine squared is the same as sine squared. All right. So we have sine squared x over sine squared x. Now we can cancel those out. It becomes 1. Remember, when you're crossing things out, it doesn't go to 0. It goes to 1. All right, let's move over to 6. Okay, so 6, we have tangent squared plus 1. So that means there's a trig expression that's squared with a +1. So we want to look for a Pythagorean identity that we can change it to. All right, so tan squared plus 1. All right, so here it is right here. Tangent squared plus 1, that's the same as 1 plus tangent squared. For addition, you can flip the order. So that's secant squared. And then we have a 1 plus cotangent squared, so we want to look for that. 1 plus cotangent squared. Here it is right here. 1 plus cotangent squared is cosecant squared. All right, so now this is where we would probably try to change everything to sines and cosines using reciprocal identities from the front. All right, so secant squared is 1 over cosine squared divided by cosecant squared is 1 over sine squared. All right, now we have what's called a complex fraction. Okay, if you remember, we did this on the unit circle when we had tangent. We had to simplify a complex fraction. So we can change this to a division problem. Okay, so 1 over cosine squared divided by 1 over sine squared. Then we can change it to a multiplication problem. Flip the right side fraction. We can multiply across now, so this is sine squared over cosine squared. Now, because both of these are squares, we can use the quotient identity that says that sine over cosine is tangent. So that means that sine squared over cosine squared is tangent squared. All right, so go ahead and try number 8. Secant x times tangent x times cosine x. This one's pretty easy. All right, so you should get it down to tangent x. All right, let's do number 9. All right, so tan squared x times cosecant squared x minus 1. So inside the parentheses, since there's a trig expression that's squared and a 1, we want to look for a Pythagorean identity that we can change it to. All right, so cosecant squared minus 1. And so that's cotangent squared. Cosecant squared minus 1 is cotangent squared. All right, so I have tangent squared x times cotangent squared x. Now from here, there's lots of different identities that you can use. You could use reciprocal identities. You could use quotient identities. So it's up to you how you want to finish this off. You can change everything to sines and cosines if you want. Right. Tangent squared, I could change to 1 over cotangent squared. That's using a reciprocal identity. I could cross cancel. I could have changed cotangent squared to 1 over tangent squared. Then the tangent squares cancel out. Again, 1. I could change tangent squared to sine squared over cosine squared, and then cotangent squared to cosine squared over sine squared, and then cross cancel everything out. Again, it'll all simplify down to 1. So it's all going to simplify to the same answer as long as you use the correct identities. Yeah?
Can you show it doing the sine squared over cosine squared?
So sine squared over cosine squared times cosine squared over sine squared. So here, because of multiplication, I can cross cancel everything out. And since everything canceled out, it goes to 1. All right, so now let's go up and do number 4. 4 is probably the hardest because you're going to see you're going to have to add fractions. All right, because of the PEMDAS, order of operations, we have to do multiplication before we try to add. All right, so multiplication here has to be done before we do the adding the cosine x. So tangent x we can change to sine over cosine. So I'll just bring down cosine x plus sine x times sine x over cosine x. So now I'm going to multiply, okay, sine x over 1 times sine x over cosine. So if I multiply those two fractions together, I'm going to get sine squared x over cosine x. All right, so I'm just rewriting the first cosine x. I'm multiplying these two fractions together. Sine times sine is sine squared. Okay. So now cosine x, I'm just going to write it as a fraction so you can see. I'm adding two fractions. So when we add fractions or subtract fractions, you have to have a common denominator. Okay. And so the common denominator or lowest common denominator between 1 and cosine x would be cosine x. Right? So I need to turn this into a cosine x so I can combine these two fractions together. So to do that, I multiply the bottom by cosine x, which means I have to also multiply the top because whenever you do the bottom, you have to do the top. So I'm going to multiply top and bottom by cosine x. All right, so then I get cosine squared x over cosine x plus sine squared x over cosine x. All right, so all I did was multiply the cosines on top together, and then multiply cosine times 1 on the bottom. So now I can add these two fractions together by turning it into one fraction, carry the denominator across. I can't combine those together yet, but I can bring it on top as one fraction. All right, so cosine x gets carried across. On top, I have cosine squared plus sine squared. Now, cosine squared plus sine squared is a Pythagorean identity. Back to my identities. What is cosine squared plus sine squared equal to? 1, yeah. So on top is going to just simplify to 1 over cosine x. Now 1 over cosine x is secant x. So that's probably the hardest type of problem, is when you have to add or subtract fractions because you need a common denominator. That's about as probably as difficult as it's going to get. Yeah.
The list of Pythagorean identities, are we going to have to memorize those?
Yeah. We're going to practice. You're going to practice writing them all out. But if you remember how to get them, you don't have to memorize them all. If you memorize the first one, sine squared x plus cosine squared x equals 1, then all the other ones you can get by just doing what I showed you how to get them. Divide and then subtract things over. All right. So number 10, we want to go ahead and multiply this out because you want to practice distributing with trig functions. So here we're going to take sine x and distribute over. So sine times sine is sine squared. Sine x times negative 1 is minus sine x. Then we'll distribute the 1 over. 1 times sine x is plus sine x. And 1 times negative 1 is negative 1. Now we can combine like terms in the middle. So negative sine x plus sine x. Okay, they're exactly the same trig function, just opposite signs. So that means they'll cancel out, become 0. So now I have sine squared x minus 1. Now sine squared x minus 1, I can look for a Pythagorean identity, and it's close to one of them. It's not exactly it, but I can manipulate one of them to get sine squared x minus 1 to equal something. So I take this one right here. What would sine squared x minus 1 equal? What is it? Close. You're close. Yeah, there you go. So if I take this and I subtract the 1 over, okay, then I get sine squared minus 1 equals something. By subtracting 1 over sine squared x minus 1 would equal negative cosine squared. All right, so this is going to equal negative cosine squared. All right, and then 11, let's go ahead and distribute that. Okay, distributing. So that's tangent squared plus tangent. All right, and distributing 1 over. That's plus tangent x plus 1. Now I can combine these two together since there's the same thing. So now tangent squared plus, okay, so 1 tangent plus another tangent is 2 tangents. Plus 1. Now I do have this, I can combine tangent squared and 1 together. There's an identity, a Pythagorean identity, I can combine those two together. What's tangent squared plus 1? Yeah, secant squared. And then plus 2 tangent x. And this is about as far as you can go with this one. All right, and then these last two problems, I just want you to review simplifying a complex fraction because you can see how it comes into play, how we did number 6. So complex fractions come in on trig expressions, and so when you have it, you want to recognize it because it's not that hard. Just got to know how to do it. Okay. So just write it out as a division problem, then it makes it really easy. So 3/5 divided by a half, then change it to a multiplication, flip the right side, and then multiply across. Doesn't take a whole lot of effort. All right, same thing for 13. This is 10 divided by 5/3. So then that's 10 times 3/5. Make that 10 a fraction by putting it over 1. You can multiply across, then simplify. You can cross cancel first, and then multiply across. But it'll simplify down to 6.